Hello, my name's Hazel Beaumont and I'm a senior lecturer in geology at UWE Bristol. And I just wanted to talk to you today about how glaciers have impacted on mostly the River Thames throughout glacial history, so starting at marine isotope stage 12. But what I thought I'd do to start with is just cover the two different types of glaciers, just so that we're all aware. So we obviously have continental glacier and the alpine or the valley glacier. The Alpine Valley Glacier being glaciers that are in the mountains and will help form and kind of construct that mountain topography and basically erode that mountain topography in a certain way. What we're going to concentrate on today, though, is the continental glacier, as we're going to look at how the continental glacier over the Arctic has advanced and retreated over time, and what impact that's had on that topography and the surrounding topography, and what bed forms and kind of glacial evidence has been left behind. So continental glaciers, we can see we've got Antarctica there, our largest continental glacier on Earth, but we can see if we look at the 3D model above, the sort of materials that are left behind. We can see kettle holes, there's floodplains, terminal moraines, there will be evidence of drumlins, evidence of moraines and tills as well. And as that glacier recedes, we will get deposition of rivers and river deposition occurring within typically glacial gravels, so diamonds. So I'm going to start at marine isotope stage 12. This graph is the marine isotope stages going from 1 on the left hand side, the little numbers across the top, so it's kind of the third thing down, marine isotope stages. It tells us what marine isotope stage we're in. And that relates to basically how many thousands of years ago we are. So we're going to start at kind of around 424,000 years ago to 478,000 years ago. We're going to start in this blue box here. On the x-axis on the left-hand side here, we're basically looking at oxygen 18, and we measure isotope ratios between oxygen 18 and oxygen 16. The other thing that's noticeable on this particular graph is this dark blue line, which is basically global temperature at that time. And we can see that basically when we have very low temperatures, we are in our glaciations, and they tend to be on these marine isotope stages that are in the even numbers. So if you look at the extent of marine isotope stage 12, we can see that it's this kind of line line down here with marine isotope stage 12 written on it. And this glaciation is the Anglican glaciation. It is a very major glaciation. It extends extremely far. It basically reforms the landscape into what we know and see today when we go out and about and walk around. Therefore, it's affecting topography. And it basically changed the direction of the River Thames to the direction in which we see today. It also helps to start develop the English Channel into what we know today. So marine isotope stage 10, it's the next one over. We can see we've got this little yellow box with this arrow. And if we look at the key, what this means is it's a delayed buildup of this Arctic ice sheet. And there's actually very little evidence of where marine isotope stage extends to, and bed form evidence related to that. And that could be because of this delayed buildup in this particular Arctic ice sheet. So what about marine isotope stage 8? Well, we can see here we've got a major map of kind of the UK throughout the European continent over into Russia, but we can start to see here this dashed line towards the bottom. So we can see marine isotope stage 8 is very, very vast. It's very, very big. It covers a whole massive area. It is dominantly on the continent, but there are river terraces in the River Thames that shows evidence of that glaciation within the United Kingdom. Marine isotope stage 6, this is basically this major dashed line that we can see through here, top of the fens, kind of up skirts the Midlands down into kind of Bristol, South Wales. And marine isotope stage 6 leaves a lot of deposits around. So we have lots of tills and moraines from marine isotope stage 6, and we do see topographic changes around Norfolk with the development of the Cromer Ridge. And within Europe, we see further development of these ridges. So marine isotope stage 6 basically left behind lots of glacial materials. We're going to jump then straight to marine isotope stage 2, because we can see on this graph with marine isotope stage 4, we don't actually drop in temperature that much from the previous interglacial. So the interglacials are the oranges, and that's basically where we have our warmer temperatures. So we're going to jump straight to marine isotope stage 2, which is our last glacial maximum. And we can see the extent of the last glacial maximum here as marine isotope stage 2. This is highly debated in literature. There are papers that present 4 or 5 different extents of the marine isotope stage 2, especially around the North Sea area. It's argued that this particular glaciation fully developed the English Channel. We see major cirques developing in and around the volcanic or the kind of metamorphic rocks within the United Kingdom, so within North Wales and up in Assynt around Scotland and the Lake District, we see major cirques being developed, so major erosion of these really hard volcanic rocks. And we also see, or we can also measure that the ice sheet actually advanced in roughly a southeast direction, or it was retreating in a roughly northwest orientation. So I've mentioned a few times river terraces. I just wanted to talk to you about what river terraces are and kind of how they're developed. So we can see here on this top part of this diagram, we've got unconsolidated sediment and then bedrock underneath. And we can see on this unconsolidated sediment that we've got terrace 1, terrace 2, terrace 3 with these blue dashed lines. And these terraces basically relate to time. So what this tells us is that terrace 1 is basically time 1, and that the river and its entirety of floodplain existed here. Over time, as that river is eroded down, it has eroded away that floodplain, and eventually we get to the height of terrace 2. And then again, over time, the river erodes down, and eventually gets to the height of terrace 3, and again erodes down, gets to where it is now. This happens in unconsolidated sediment. Where you have solid bedrock, the same processes happen, it obviously takes longer, and they're called straths. And I've talked about the River Thames a couple of times in kind of looking at the kind of how it's developed over time and how it's been influenced. And what this image is showing us is basically a map of the river and where we see it exiting into the North Sea with particular locations on. And then we can map those locations down to these coloured numbers. And these coloured numbers are basically our interglacials. The brown, or the kind of dark grey, is the interglacial material. The material around it, this kind of white material with lines in, is the glacial gravels. So it's the glacial material, so the material that was deposited during glacial times, and this dark grey is the interglacial material. And it's in that interglacial material that we can find evidence of life. So at marine isotope stage 11, up here, this pink one, we can see evidence of bears and deers and moles and human artifacts. Here we can see the pre-fleet grays deposits, pure fleet grays deposits at number 9. Pure fleet we can hopefully see on the map is here, so between Aveley and Swanscombe. And in marine isotope stage 9, we see further evidence of bears and shrews, hyenas, human artifacts. So we see this evidence within this interglacial material. At number 7, isotope stage 7, at Aveley, again we can see Aveley on the map. So it's the West Thurlock deposits. You can see evidence of mammals and evidence of northern voles, and again human artifacts. And then when we get to stage 5E, it's known as Trafalgar Square, kind of in central London. Within this interglacial materials, what we actually see evidence of is hippos and deer. We don't actually see any human artifacts in this material as evidenced here. So we can see over time how people or animals migrate and move around in relationship to these glaciations, how this river is influenced by this glaciation and by these different glaciations. And I'm just going to leave the summary there and just say that there is a Q&A. So if you do have any questions, I'll happily try to answer them. Thank you for listening.